How's it going? Listen to my voice. So you started 2018 number 1, and you're like, man, this is kind of tough. This is kind of difficult. What's even going on with this? Luckily for you, I have it here. Let's break it down together. Are we going to do the question together in its entirety? Absolutely not. Are we going to break down some key points of it? Let's go through it, right? So as we're reading here, the first thing I would probably note about this question is it is a 13-minute question, right? So that's the time frame that I'm working with. And what do we have here? Just by looking at this, if I don't read anything, I'm seeing a spacecraft, right, at a distance r, and we see that this is the Earth. So the second I see this diagram, what I'm thinking initially is UCM, and this has got to also be FG, right? This is going to be a combination of those two, and I'm thinking that without even really reading anything. But let's keep going and see what else it says. Spacecraft of mass m, okay, like that. Clockwise circular orbit. Circular orbit important because that means that UCM is valid. Let's keep going. Then the mass of the Earth is ME. Inventive. Me? I'm the mass of the Earth? I didn't think I ate that much bread. Kidding. I did eat half a loaf the other day. It's homemade bread though, so it's okay, I guess. So here, so in the figure below, draw and label the forces. Forces, not components. Remember, whenever drawing components, right? And then each force must be drawn by a distinct angle arrow. What I will say for this part is remember, when we talk about these style questions, because it's UCM, we would be doing FNet, mac and cheese. And the next thing we always did, we said, what was that FNet? For this problem, it should be FG. So think about what direction FG would be. That would probably help. And now, if we keep reading with this, derive an equation for the orbital period t, and you see in terms of these things that are allowed there, and you don't have to draw anything. Since we're deriving an equation, this means we're doing algebra. Because we're doing that algebra and we're looking for orbital period, we have to look for a way to connect all these things. It's pretty similar to what we had done in the past. This is where we would be taking these two equations and smashing them together. Now, the part that you might be stuck with, right? So if you let's pause for a second, so you can pause the video. If that's all you needed, go do it. You need that extra little push. I will give it to you. We're trying to connect orbital period into this, which means time. The thing to remember about UCM is things move at a constant velocity, and things that move at a constant velocity are distance over time. Okay, and this is a trick that we had actually done, if you remember that. But if we think about how fast this thing would go, well, this should be a circular orbit, right? So it's 2 pi r as the distance, and how long does that take? It takes the orbital period. So this would be the v, that I could then take this, and that would probably go in there for my mac and cheese. So that would be a little assistance with that part. And then part 2, I have a second thing, right? And then we're looking to see if it's greater than, less than, or equal to. This entire question, all of part 2, you're looking at the algebra you did and seeing, does mass have an effect or does it not? And now we have a new orbit, right? And now we want to know if the new orbit different, right? Is it bigger or smaller, right? I would say for this, right, it now has a greater radius r, and we're looking to see is the speed different, right? Go back to your equations, and this is where I would go back to mac and cheese and FG and see, what effect does r have on those equations if you were to solve for v. This is just a quick video. Hope this helps push you in the right direction. And if not, email me if you have any other questions. Until next time.